All right. Everybody else good? Anybody else need this? Did anyone not get their test back yesterday? Okay. Everybody else good? Anybody else need this sheet? Anyone? All right, so we're going to look at the other side of this in a minute. I'm going to build up to it. So what we've been focusing on, yesterday we spent the whole class talking about how to find the list of potential zeros. You guys all with me? Potential rational zeros. Somebody remember that? Okay. And the last thing I said was I was going to help you because those lists get big sometimes. And the whole idea is once I've got the list of potential zeros, I have to check them to see which ones are. And that could take, if you have a list of 20 freaking numbers staring you in the face on a test, you're like, no, this is not fair. So I'm going to give you several ways. We're going to talk about several ways where that list can shrink, which is good, because then I have less stuff to check, right? I'm not going to waste time. So everybody, let me stop for a minute. So you guys looking crazy, but it could just be you're not awake yet.
Are you talking about what to divide by?
Yes. So remember when we made the list and it was the factors of the last number divided by the factors of the first number? That's the list of possible zeros. Those are the things that could make the polynomial zero. Okay. So if I have, here, let me make one that way it might work. I have some, we'll talk about, and ooh, that's neat. Okay, so, oh, that's not very interesting, Jeff. Screw it. If I have this, I'm just going to make one up that won't work, but screw it. Sorry. Okay. Can you guys remind me how, in fact, let me make this a little more interesting there. Can you guys remind me how to create the list of possible inputs for x that would make this zero? Good. So what are the factors of 18? 1, 2, 3, 6, 9. Yeah, now we're doing this. 18. Just remind me real quick, what's the square root of 18 roughly? What's the square root of 16? So what's the square root of 18 roughly? 4. Roughly it's 4. So around 4 should be the turnaround point, the point where I can start pairing factors with previous factors. Are you guys, you don't have to know that. I just thought I'd share it with you because it's something I know. You don't have to know that. Do you guys remember making lists of factors? In fact, you're like, yeah, yesterday. But I mean before this class. Making lists of factors? Mm-hmm. No?
No,
yeah.
not that way. Only just the one that you split.
Oh, the prime factor tree.
Yeah.
Okay, so this is not the prime factor tree, obviously. This is more direct. This is just, numbers that go into this.
Mm.
Not, and when you prime factor something, I call that the DNA of the number.
Yeah.
Because you break it all the way down to its little parts. Yeah. Okay, let me stop for a minute. Love you guys. You guys remember doing this yesterday? Why am I not done yet? How do I take into account this guy?
It's divided.
Yes, because the numbers in front would end up on the bottom, so the numbers in front would contribute to fractional answers. And of course, the factors of 4 are 1, 2, 4. So then I have to make all the possible, so I get the entire first row because it's divided by 1. So all these divided by 1. Then divided by 2, the only new stuff is 1/2, 3/2, 9/2. Is that cool? Everything else is even, so when I divide it, I get a number I already have.
1/4.
Sorry? Oh yeah, I'm getting there, but I just did over 2. 1/2, 2/2 I have, 3/2, 6/2 I have, 9/2, 18/2 is 9, I already got it. Then 1/4, 3/4, 9/4. 6/4 is 3/2 I got, 18/4 is 9/2 I got. So everybody cool with that? Did that a little fast, but you literally, what I do is I take the top numbers divided by the first number on the bottom, the top numbers divided by the second number on the bottom, so forth. So I don't miss anybody. How long is that list? 6, 7, 8, 9, 10, 11, 12, 24. Because there's plus or minus, yes? Is everybody with me? Okay. That I just wanted to do this to remind you what we did yesterday. So what I said yesterday was, dear God, Jeff, dear God, let there be a way to cut the number of things down that I have to check. Yes? Is everybody with me? Some of you guys still a little clear asleep, but it'll be okay. You're gonna wake up. So what we did yesterday. Okay. And this is where yesterday we would have just started trying these. Let's focus on methods to cut down on the number of things I have to try. Does that sound good? You're distracted because I know you have questions. You're not talking. All right. I'll try not to look.
I'm just tired. That's why I look.
Okay. Dang, it's my face. All right. So here's the first level. There's 2 things I'm going to tell you about. 2 things. One of them, when it works, will cut your list in half. But it doesn't work often. So I'm going to tell you about it. I'm obviously going to create problems on the test that it actually works for, just to make sure you can use it and see how it works and to cut your list down. But it doesn't work all that often. So you're like, oh great, sounds great, Jeff, thanks. But when it works, it cuts your list in frickin' half. That's pretty good to look at just in case. So here's the idea. Can anyone tell me, if I had this function, I want you to think about it for a second. Could this function, all right, you ready? Could this function possibly have positive zeros? Could this function have positive zeros? And right now, before you really start to think about it, you're like, how the shit would I know, Jeff? I want you to think. There is a way to tell. Without doing anything really, there's a way to tell me if this thing has positive zeros. What does a positive 0 mean? What do I mean when I say that? Give me an example.
0.
There's no minus here, positive, yes? Positive, what's a 0 mean? If I told you -5 was a 0, what would it do?
It would, if you plugged it in, you'd
If
get
I
0.
plugged in -5, I would get a 0 out. So everybody with me? I want to make sure we all remember the definitions. So a 0 of a function or a 0 of a polynomial is a value that if I plug it in, I get 0.
So positive 0 is not possible in this one.
Maybe. I haven't heard an answer yet. It's not what I haven't said that.
Well, everything up there is positive, so any positive number.
So if I plug in any positive number, isn't this positive?
Yeah.
So could 4 positive numbers add to be 0?
No.
I need everybody to be with me on this because this is it's a really, really basic idea, but it's a little weird at the same time. I need you to see this. If I plug in a positive number, none of the numbers subtract each other. There's no way they could make 0. So right there, if I made, let's see, I'm just 50, it's okay. Not a great example, Jeff. Here, let me make one change. 48, there we go. The way you might have made a D into an A when you were a little kid. So make that last number 48. Okay. What's the list of possible zeros? It would be all the, how do I make a list of possible zeros? It would be all the,
Negative. No,
all the,
factors.
it would be all the factors of 48, yes? So I'm just going to make the possible list before I apply what we just figured out. So it'd be plus or minus 1, 2, 3, 4. What's the square root of 48? Almost. The square root of 49 is?
49, 9.
Square root of 49 is? 7. So when I get around 7, I should be able to stop thinking and just start pairing. So 4 goes into 48. What else? 6 goes into 48. I'm there. 6 times what is 48? Okay, it's going to be just me today. Okay, so 4 times 12, 3 times, anybody know? Maybe. This is the freaky one, 3 times 16. 2 times, you can do it,
24.
you can 24, and then 1 times
I don't know.
48. So right now, as it stands, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 20 numbers. So ready with me, just like we got a minute ago. But this idea, if I apply it, I can cut my list in half. Because what numbers could not possibly be zeros?
Anything positive.
Any positive number can't be a 0. I need you to see this. It's not for me. All like, what the hell are you talking about, Jeff? So real quick, x plus 4. Could a positive number make that 0? X minus 4. Can a positive number make that 0? Hell yeah. Because part of it is subtracting from the rest of it. There are opposite signs in it. Therefore, a positive input could come out to be 0. Yes? This one's got nothing but positive terms. There's no way a positive number can make it come out to be 0. So my new list would just be the negatives, and now instead of 20 things, I have 10, which is still a lot, but it's freaking half of what I had before. I mean, right there. And I haven't even told you the next thing I'm going to tell you. So right there, I gave you a way to sometimes cut the list in half. Okay. And let me formalize the idea. How many times did a term change signs from one term to the next? This is a weird idea. But what is the first term, positive or negative? That's given. Positive. The next term, did it change signs? No. So how many times did the sign change as I look through it? 0 times. So if I give you a polynomial and the sign doesn't change at all, there could be no positive roots. So let's look at the other extreme. What if I give you a polynomial and considering what I just said, does anyone see the important part of this? Could positive numbers make this 0? Hell yeah, because some of it's subtracting from other parts. Totally. Does that idea is so simple. But it gets lost in all the shit. I mean, that idea is just simple. You gotta have parts subtracting in order for a positive number to make it 0. So that is a no. What about negative numbers? That's where this gets murky.
No.
could it have a negative 0? The answer is no. There are no negative numbers that could possibly make this 0.
But there's positive signs.
Sorry?
There's positive signs.
But
So
only on
true.
the
But
matrix.
what kind of number am I plugging in? What
Negative
kind
number.
of number am I plugging in? A negative number. So watch this. If I plug in a negative value, what happens here? Besides, Jeff gets really tired right in here. My God, Jeff, why'd you have to make it on? Now, real quick, I need you. Do you see what I did? This is sort of like finding even odd symmetry, but I plugged a negative in, correct? Like a negative x. Are you with me? Do you guys, when I plug a negative into an even power, what happens?
Yeah, positive.
Yeah, the negative cancels, yes? And when I plug a negative into an odd power, stays negative, yes? So do you see the shortcut to evaluate this? Every odd power stays negative. Every even power, this piece becomes positive. This is still negative 7x to the 4th. This one changes sign because it's an odd power. This one stays the same sign because it's an even power. This one changes sign. This one, of course, doesn't give a shit what x does. Now I can analyze it the same way we did the first one. Do the signs change? No. If I plug a negative number in, this is negative, that's negative, this is negative, that's negative, this is negative, that's negative. Is there any way the answer could be 0? No, for a very similar reason to the positive one we did earlier. Nothing is canceling each other. There's no freaking way it could become 0. So if I look at the polynomial as given, and there's no sign changes, there's no positive roots. No positive zeros. If I plug a negative x in, and the result has no sign changes, there's no negative roots. And then again, I can cut my list in half. I love you guys.
Can you say that last part? There's no what?
No sign changes. The great thing about this rule is you evaluate it the same way. Look at the polynomial they gave us. If there's no sign changes, no positive roots. If they give me a polynomial and I plug a negative x in and there's no sign changes, there's no negative roots.
There is one negative root on this one.
No.
Did I type it in wrong?
Yes.
I must have.
Yes, you did.
No, I typed it in right.
Here, let's look at it. Here, I'll use Desmos. Desmos is nice.
It's like
All right, let's see. What was it? It was x to the 5th.
Negative 0.24.
Minus 7x to the 4th. Plus 11x cubed. Minus 10x.
Oh, I didn't do a negative 10x squared. I did a negative 10x. That's
Yeah, that sounds better. Yeah, it was impossible. It was simply impossible. So I knew you typed something in wrong, but I appreciate you. Listen, guys, I'm just a dude. I'm just a guy. Sure, I've learned a lot of math, but dear God, do what he's doing. Be like, I don't know if this guy's talking. I mean, shut me. I mean, what the shit? I could have gone crazy for a moment. Yes.
Right before that, you said, looking at polynomial, there's no sign change as well.
There's no positive roots. Because nothing would be taking away from anybody else. It would only grow. It could never become 0. And the negative one is really nice. If you want to check out for negative roots, you plug a negative x in. And then if there's no sign changes, there's no negative roots. Feel neat to point out. Some of you guys don't take notes, which is neat. I'm very jealous of your memory. All right. What if I have neither situation? This is where things get a little bit freakier, and I'm not gonna spend terribly much time on this. All right. Are there sign changes? Could there be positive roots? You guys with me? Now here's what's neat. So then this didn't do shit for us. Can somebody tell me exactly how many times did the sign change as you scan through from term to term? No? Did it change yet? Did it change yet? It changed once, twice. You guys see that? It changed 2 times. Can you stop for a minute? So here's what that means. This is less useful, but it is useful. The number of times the sign changes tells you how many possible positive roots there are. So there are 2 possible positive roots. Okay, that's where I really want you guys with me. Do you guys remember when would complex roots show up?
And there's a negative inside of a square root.
Where would they come from? Huh? Sure, but where's the square root coming from? Where's the square root coming from? When would there be complex roots? Where would they come from?
Oh, what is it about?
They would come from a quadratic that we can't factor. We would use what then?
The
Quadratic formula.
And if there's a negative in the radical, that's when there's a complex answer, right? So how many complex answers have to show up at a time? Because what is quadratic form? Negative e plus or minus. So if the inside of the radical is negative, how many imaginary answers do I get? How many complex numbers do I get?
1.
2! They always show up in pairs. So for this polynomial, since there are 2 sign changes, there's either 2 positive real roots or none. Because maybe there's complex roots instead. And how do complex roots show up? In pairs. Two or 0 positive roots.
And it's,
Say again?
I just answered my own question.
I love it. Now, how do I investigate the negative roots? You guys know. How do I investigate the negative roots? Plug it in negative x. And the shortcut is every even power is going to stay the same sign. Every odd power is going to change signs, yes? So this stays the same, this changes. This stays the same, this changes, this stays the same, of course, because 1 don't give a shit what x is doing. Do you guys see how I did that very quickly? And if you don't like that, plug a negative x in, actually do it. But the more you know, the less you should have to do. How many sign changes are here? 2. Positive, now it's negative, that's 1 sign change. Negative to positive, that's 2 sign change. How many negative real roots are there? 2 or 0?
Is it 2 because of 2 sign changes?
Yep.
Or is it 2 because it's complex numbers?
2 because 2 sign changes.
So
It
if
goes
there's 3 sign
down by
changes-
2 because complex number shows up in pairs.
I'm sorry, but I'm not understanding. Where does the 0 come from? Like what? Epsilon.
If it's not a real root, let me put the word real in here, I gotta remember. Positive real roots, negative real roots. If it's not real, what is it?
Complex.
Complex. When complex numbers show up, how many show up at a time?
2.
2! So either they are
Oh.
2 real roots, 2 positive or 2 negative,
Or they're
or
not.
they're not real, which
Because of-
means there'll be 0 positive or negative real roots.
Makes sense.
Why didn't x4 become negative x4?
Because what is negative to the 4th power?
Okay.
Yeah, so all the even powers stay the same sign. All the odd powers change signs. Because when I raise negative to an odd, the answer is negative, which will change the sign of what it used to be. When I raise negative to an even power, the negative dies, so it stays the same sign. So here, let's do this. Let's graph this thing. Let's see what I have created here. What was it again? It was x to the 4th. I like 7 today, so shit. 7x cubed minus x squared plus x plus 1. So not very interesting, damn it. That's too bad for me. Here, let me do one thing. I'm going to change this a little bit so it does what I want it to. I think, yes. Okay, I just changed one of the coefficients. It's still negative, you with me? I need you guys with me. Can you guys see how many, oh, this one's a little weird. Let me think about this for a second. It's not doing what I expected. Oh, did I put, is it minus? No, it's plus. Minus, plus, yeah. 1, 2, okay. And then, give me a second. 1, 2. Oh, there. Okay. Sorry. All right. It wasn't doing what I thought, and I didn't realize it's over here also. Okay. Can you guys tell me how many negative real roots that has?
Yep.
You can just see them, right? Can you guys see them? What are roots again? They're also called zeros, which are also called x-intercepts. So can you guys see the 2 negative x-intercepts? Okay. Are there any positive x-intercepts? No. But watch this. All right. So now I know, in this case, when I put a 6 here, now I know there's 2 negatives, no positives, yes? Okay, but watch, I need you guys with me. If I make one little change, okay, there we go. I went down too far, dang it. Oh wait, I changed it totally, didn't I? I didn't want to do that. Let me see if I can make this happen. This will be very exciting for everybody. Oh, almost. Oh, there we go. Okay. All right, I'm sorry. I need you guys with what I'm doing. Am I changing the sign of any term right now? Okay. I'm just showing you, because everything we did was based on positives, negatives, not numbers. If I change this one number, it's still positive. If I make it, I forgot what I made it now.
One. You made a 1.
1? 1's even better. Okay. Now, how many negative roots are there?
2.
And how many positive roots?
2.
So, we didn't look at the numbers. We just looked at the signs. And that's why it's kind of like, well, it could be 2 or it could be 0. The numbers themselves are what kind of pushes it up or down. And then it either hits the x-axis or it doesn't. When I'm just looking at the signs, I have no idea if it's actually going to hit the x-axis or not. So when I go back to what it was, watch this piece here. If I put the 7 back, see how it lifted it up? Now it's not hitting this axis anymore, so there's no positive roots. Okay, I love it. You would, Jeff. Okay. So that's called, there are several people in mathematics who did too many things. Quick side note, do you guys know what this is called that we keep using to graph things?
Graph?
Not the XY plane, not just graph. What is that coordinate system called? Do you guys know? Starts with a C. You know, a coordinate system, no.
Compass? Compass?
No. Has anyone ever heard Cartesian coordinate system?
I've heard of this. Does that come from the name Descartes?
Descartes, yes. So Cartesian coordinate system. You probably have heard this, but if you never actually have, then a little piece of me just died. I'm going to tell you this story. Descartes, René Descartes, he was a philosopher and a mathematician. All the earlier mathematicians were basically categorized as philosophers because Mathematics is the most basic philosophy of science. He was sick in bed. Yes? Everybody see him. He's right here, sick in bed. Look at him. You're sick. He's sick in bed, and he's like looking at the ceiling like, oh God, this is years before we learned about antibiotics. So he's looking at the ceiling, and he sees this fly on the ceiling. And the fly is walking, yes? And he thinks to himself, I could identify where that fly is based on how far left and right and how far up and down. This is the urban legend. There's some indication with some people wrote, but we don't know that's real, but it's kind of neat to me anyway. Are you guys at all with me? So he invented the XY plane, which is why we call it the Cartesian coordinate system, because we give him props for that shit. That's pretty big. How often do we use the damn thing? All day. Okay. He also is the one that came up with all this stuff, and you're like, God damn it, why didn't you just die? You're okay. This is called Descartes' rule. This should be over here. Of signs, which is, because mathematicians are very creative. Descartes did it, and he was looking at signs, and it's a rule. Okay, there we go.
What is it?
Descartes' rule of signs.
No, but what is it?
I'm sorry, the whole thing we just did.
Okay.
Everything we just did. What did we look at to determine this stuff? The signs. So again, math people very creative. It's a rule about signs that that guy made. Let's call it that. Yes, ma'am.
So for the or 0, is that only a thing for quadratic?
We are, there's, quadratic is gone. We are beyond quadratic, yes? That's quadratic. I mean, it works for quadratic. It works for polynomials, period. It just works for polynomials. The or 0 is because, again, complex numbers show up in pairs. So if I could have two real roots, but if I don't have any positive real roots, they must be complex. And then we get that thing, they're in the plane up here somewhere. Remember that from the video? You picked it up, it was all colorful. I showed you that video, yes?
Does it work for linear equations?
I mean, yes.
Because like, if you have a negative x plus 1, then that's one sign change, and then
And if you put a negative x in, you get no sign changes. So there is a positive root, but there's no negative root. So yes, it works for every polynomial. Okay. Yes, sir.
Last question. Would it always be or 0 for the roots of the shape?
No. Okay, you ready? Let me make one more example. Jeff. Oh, Jeff. Okay. Okay, how many times did the sign change? Let's see, 1,
3 times.
2, 3. You guys see that? So how many positive real roots are there?
3.
There's 3. Nope. How? If they're not real, they must be. Come on. If they're
Complex.
not real, they must be complex. And complex shows up in
Pairs.
pairs.
Oh, so 1.
3 or 1.
Oh.
I didn't go to 0. I went down by 2. Sorry. What's up?
Napkins.
Oh, no. Well,
Napkins.
oh, napkins. Don't use this. That would hurt. No, I'm sorry, man. You gotta run out into the bathroom real quick.
Yeah.
Sorry, buddy. Sorry. He's like, oh, thanks. That would hurt.
So if it was 5, it would be or
5 or 3 or 1.
I'm saying if there was 5.
Yeah, if it was 5, it would be 5 or 3 or 1.
Got it.
Because either all 5 are real, or some aren't, which means 2 could be complex, so there'd be 3 real, or there's more complex, which means there'd be just 1 real. So you subtract 2 until you can't subtract 2 again. if, I need you to be with me on this. How do I say this? If there are 7 possible roots, real roots, and if they're not real, they must be complex. So either all 7 are real, or 2 are complex, so 5 are real, or 2 more are complex, so 3 are real, or 2 more are complex, so 1 is real. Now this is good information, to be honest, because I'm guaranteed, in this case, I'm guaranteed to have 1 positive root. Real root, yes? So then if I have a list of shit, I'm gonna try out all my positive ones first, because I'm guaranteed. Especially if my negatives come out to be 2 or 0 or something, yes?
So if you have 5 positive, or if you have 5 real roots, then it'll be 5 or 1.
Nope.
So a good mental shortcut would just be subtract 2 from whatever the real.
So if I had 5, let me do it like this. If I have 5 possible real roots, yes? They could all be real. That's one way. They could all be real. If some aren't real, what's the least number that would not be real? Complex numbers show up in
pairs.
So how many of these, what's the least number of these? If some of them aren't real, what's the least number that could be complex? 2. So the first 2 are, so what's this? Is this 5 real? Or how many real is this one? 3. What if more are complex? How many more would have to be complex? 2, because they show up in pairs. How many is this?
1. The
The shortcut, you go down by 2 each time because complex numbers show up in pairs. So either, I need you to see this, this is so cool. Remember that dip that when I changed it went down so they hit the x-axis? So either that's up here and there's none, or it's down far enough so there's 2.
What if it bounces?
Then that's a repeated root. And that would be real.
Okay.
So there would still be 2 answers, they just both happen to be the same answer. Okay, I like it. Yes?
So you're saying every time it's gonna go down by 2?
Yes. Thank you. Yes, that's what I'm saying. Okay. So sometimes it'll go down to 0, and sometimes you'll stop at 1. Because you can't say there's -1 root, that's weird. Yes. Okay. Alright. Now listen. I want you to understand. This is not like intuitive at all. This is not intuitive at all. But it is a little bit of a tool. So at least if Descartes doesn't do the ultimate great thing, which is cut my list in half, at least the way it's not 0 shows me what could happen, right? Okay. Let me talk about the other thing that I think you'll like a little bit better. Potential. Let's see. And in order to do this, let's do this. Let me give you this. Oh shit, wait a minute. Oh, this is the same one. Here. So on the other side of your synthetic division, there's this. So right here is Descartes' rule of signs. We're going to talk about these 2 next, but I'm not going to try to make up a problem on the fly that does what I want it to. It's not easy to do necessarily. Yes?
Do you have an extra?
I do. Anybody else need one? Okay. And this is just on the other side of the long division, in case you have that. Who else? So let's see. Let's before we talk about these, let's kind of build up to that. What are all the possible rational zeros for this polynomial? What's kind of nice about this polynomial for making this list?
No A coefficient.
Good. There's just a 1 out front. So I'm not going to have any possible fractional rational answers. But what are they? Let's see. Yeah, so I look at this number here, yes? So it's 1, 2, 4, 5, Good. So now I can make the turn. Square root of 40 is roughly 6. So I'm right at the turn point. So now 8, 10, 20, 40. What is that? 16. That's still pretty big. That's really big if I have to kind of guess and hope. So first thing is, how many sign changes do you see in this?
2.
Yeah, there's 1, 2. Okay. So how many positive real roots could there be? 2 or 0. What about the negatives? What would I have to do to figure out the negatives?
Plug in a negative.
Plug in negative x. So all of the odd ones change sign. All of the even ones stay the same. So how many sign changes are here? 1, 2, 3. Yeah. Is that cool? So how many negative real roots are there?
3 or 1.
3 or 1. So you see I'm guaranteed to have at least one real negative root. I might have 0 positive. No, I might have 1 negative and 2 positive, but in terms of being a gambling person, I would check my negatives first because I'm guaranteed one of them works, yes? Now, did Descartes help us out much? No. When does he really help us? When there's no sign changes in one of those two, because then I can just cut my list in half. He didn't do that for us here. Damn you and your fly observant self. So, can you do part C for me? We'll talk about what they mean in a minute. Can you just do this first part? Synthetically divide by 8, which means put 8 in the penalty box, and then by negative 8. Bless you. So just in case, so in the penalty box I could put 8, and then I put the coefficients. And I'm not missing anybody, so I don't need any zeros. And I'll show you, are you guys getting really big numbers?
Yeah.
Okay, I'll show you something you can do. So bring the 1 down, 8. Add, multiply. Add, is that right? I think it's right. Yes, sir. And then multiply. That's 344, I believe. And then add, multiply. 2,400 something. Big positive, big positive, big positive. So at the end, can you guys see very quickly it's not going to go in? Can you guys see that? And do you see where I kind of gave up on the specific number? And I'll show you why in a minute. I know it's not going to go in. I'm doing a problem where I don't give a shit what the remainder is, unless it's 0. Yes?
Where'd the 344 come from?
I don't know. 43 times 8. I did that quickly. So let's see, 320. Yeah, 344. Yes. Right? I mean, synthetic division doesn't change how it works. Bring it down, multiply, add, multiply, add. I need you guys to see this, because who gives? All right. So real quick, what did we just figure out? This is x minus 8 times x to the 4th plus 9x cubed plus who gives a shit, all positives, yes? All right, I really want you with me on this. This kicks so much ass. This is related to Descartes' rule of signs, but it's nowhere near as free. If I synthetically divide by a positive number and the result does not change signs, no number above what I just divided by will work. It's what's called an upper bound. Did I have numbers above 8
Yes.
in my list? Yeah, 10, 20, 40. I can kill those. They won't work. Why does that make sense? If I plug a number bigger than 8 into this, I get a positive number, correct? And then a number bigger than 8, well, there's no way that a positive number could make this 0 because they're all freaking the same sign. Same idea from Descartes. But you can apply it very quickly. If you synthetically divide by a positive number and your results don't change sign at all, you've just discovered an upper bound. No number above 8 will work. And 8 itself, did 8 work? So I can throw that shit out. So I actually just in one fell swoop, I eliminated 4 numbers from my list. So what do you guys think? I don't know if anybody's gotten to -8 yet. So
It
there's
doesn't work.
8. Sorry?
It doesn't work.
Oh yeah, I know it doesn't work, but what kind of results did you get? Let's see.
Huge number.
Sure. What's important is what their signs are.
We have 2 negatives.
You ready? Let's see. 1, 8. Sorry, -8, Jody. -7, 56, 27. Double check me as I'm going. Is that 216?
Yes.
-251. Is that 2,000 zone?
Yes.
2008?
Yes.
Neat. And it's going to be positive. So this is going to be positive. This is big negative, so this is going to be negative. And again, this is directly related to Descartes. Did the signs change all the time? Did the signs change every time? Did the signs change every time?
Yes.
So that is a lower bound. There could be no answers below -8. So if I divide by a positive number and they don't change sign at all, that's an upper bound. If I divide by a negative number and they do nothing but change sign, that's a lower bound. So what does my list of possible roots look like? Did 8 or -8 work? No, so we can kill those. And then we also found out that's an upper bound and that's a lower bound. So nothing above or below those works. So can somebody figure out what the new list is?
Positive or -1, 2, and 4, and 5.
Yes. Much, much, much smaller than it was before. Yes? And listen.
So what does it mean
Go ahead.
when you say lower bound? It's kind of confusing because you think like -8, lower bound means it's lower. It's bound to be lower.
You ready? If you're looking for, so I remember last time I was trying to find a place to live. This is thankfully a long time ago. I was searching through something and I decided I put an upper bound on the rent because I'm a teacher, but I also put a lower bound on the rent because if I didn't, all these weird little stupid garages would show up and shit. I'm like, I'm not at the point where I have to live in a garage. No thank you. So I put a lower bound. Yes. What does lower bound mean? If I don't want like a $25 a month garage to show up, I would set the lower bound at maybe $600. Anything below 600 is probably either a garage or somewhere I don't want to live for sure. Yes? You guys with me?
Yeah.
What does that mean? If 600 is a lower bound, what prices would not show up? Anything below 600. So if -8 is a lower bound, what won't be answered? Anything that is below -8. So I have a bound that's a lower bound and an upper bound. The only possible answers are between those two. And that's why I can kill positive 8, 10, 20, 40, negative 8, 10, 20, 40. Cuts out the middle part to be good. Yes?
When you for part C, when you said divide synthetically by 8 and -8, do you pick that number because it's like halfway in between?
Good. And this is a beautiful. So now somebody, I think the other day it was either you guys or my other class said, do we always want to try 1 first? And I'm like, actually, you want to try something in the middle first. Because if you try, and what do I mean by that? I mean, if I look at my list, I'm not going to try freaking 40. I'm not necessarily going to try 1, but there's nothing wrong with trying 1 because it's the easiest one. Why not? I'm going to try something in the middle. Because there is a good chance it will end up being some kind of an upper or lower bound, yes? And what does that do for me? Chops a bunch of shit off so I don't have to worry about it anymore. So how do I put together my tests? I tell you this, I put them together exactly like this. I would have exactly the same questions. So I'm trying to push you in the direction of cutting your list down. And I normally put the one that I really want you to work on the most is going to be one where Reynard, that's good, Jeff. I'm going to call him Reynard. Rene Descartes, where his rule works, where you can cut the list in half. Are you guys with me? Are you guys all with me? So like you can cut out all the positives and negatives. You are, and then you have bounds, and then they ask you divide by 5. What's it mean? You're like, oh, it's a bound. Holy shit! And then you cut off more shit. Go, man. So then you end up with like maybe 4 things to try. So I don't care how unlucky you are, you're going to find something that works. Now let me ask you a very key question. Why did I throw 8 and negative 8 out?
Because they didn't.
Very stupid question, right? Why? Because they didn't freaking work. Yes? If I get something that works, should I throw it out because it worked? Because it could work again, because it could be multiplicity more than 1. So if I divide by 2 and I get a 0 remainder, don't throw 2 out because it could work again. It could be a higher multiplicity, yes? Are you guys with me at all?
Yes.
Only throw shit out if the bounds cut it out, or Rene Descartes says throw it out, or it didn't work. Renard, yes.
Freaky question.
Sure.
Would there ever be a possibility where, like, let's say negative 8 and positive 8, negative 8 will equal to 0, but positive 8 would not?
Oh, hell yeah.
And then what would you do with the lower and upper bound? Would you just find...
No. If negative 8 makes the output 0, that means x plus 8 is a factor.
Right.
There's no reason x minus 8 would also have to be a factor. Right? That's what you're really asking. Now, could negative 8 be a lower bound but 8 not be an upper bound? Hell yeah. Hell yeah.
So what would we do in that situation?
No,
Find
you-
the next number?
You just keep going. Okay. So, can everybody do me this favor? Here. All right. Same thing we did yesterday. Is anybody synthetically dividing this already? No. Okay. You're fine. I was going to give you a little. You are? A little tear.
No, I
Oh
got
no.
it.
You have a question.
Yeah, I know.
Please shove that back in. Okay. What's up?
Once you have your updated list like that, can you, is it
Start trying shit.
is it possible to find another upper bound or lower bound?
Oh hell yeah. Hell yeah. Real quick. If I don't want to pay more than $2,000 for a place, which nowadays it's like, better grab that garage. Does that mean I don't want to pay more than $3,000? So if I find $3,000 to be an upper bound, could $2,000 also be an upper bound? Yes. If nothing works above $2,000, then obviously nothing works above $3,000. So when I do the work, I could find a bound, and later I can go, oh, there's a lower bound. I just didn't know. I mean, there's a
Lower upper bound.
yeah, there's a smaller number that's a bound. Okay, and again, these are all little details that you don't have to memorize. It's just when you find a bound, you can chop stuff off. Later you might find other bounds, and you can chop more stuff off. Great, or you might not. So, can somebody try, all right, let's try this again. 1, negative 1. Who wants to synthetically divide by 1, negative? Anybody? Serenity, smart person? Anybody else? You're going to divide by something, damn it. So you're doing positive 1, Serenity? All right, who wants to do negative 1? Kyle's got negative 1. Positive 2? You got it? Liz, negative 2. Oh, okay, Marie. Positive 4? All right, you got it? And then negative 4. You got it. Positive 5? You're like, man, I don't want a 4. Negative 5. Negative 5? You got it. Okay. And everybody else, just pick your number. Because you never know, the person doing it might make a mistake. So be ready. Okay, go for it. I'm just going to try something. Because I don't know what the answer is, even though I made this problem. No, that won't work. think. Oh no, that won't work. What did I say earlier? There it is. That won't work. Does anything work, Jeff? Let's see. That don't work. Oh, I think this works. Yes. I found one that works. Yeah, okay. Is everybody getting any that works? Anybody? You got 2? You got 5? 5? No, what'd you find?
Yeah, 5.
5? Okay, so we got 2 and 5. Anything else that worked? Alright, so let's do this. So all I did was, I set it up and then I just start trying stuff out in my head. So I'm almost certain I did. But I got 5 to work. So I agree with you. So let's see. If I do 5, 1, 5, 6, 30, 1, 5, negative 30, negative 150, negative 8, negative 40, 0. I know I did that fast. Who cares? You guys can all do that shit. Just multiplying it. Now if I try 2, 1, 2, you said 2 worked, right? 8, yes? I love you guys. You're all like, just keep going and see, Jeff. All right, fine. 4, 8, 0. Okay, good. So nobody else got anything that worked?
-4.
Negative 4? Okay. So if I keep going, negative 4. Did I do this stacking thing with you guys before?
Yeah.
Okay, good. And by the way, the stacking thing, if you have a pencil, it might work as you can erase. And if you don't have a pencil, yes, you do. Stop using pen, damn it. So then 1, negative 4, 4, negative 16, 1, negative 4, 0. Okay, so what did we get? What information did we get? What are factors of this for sure?
Minus 5.
-5.
Good, x minus 5,
Minus
Minus
2.
x minus 2,
X plus 4.
x plus 4, and what did we get that was left?
X squared plus 4x plus 1.
And how do you know it's x squared? Because this was, where'd it go? 5, 4, 3, 2, Earth, B, no, sorry. Let me stop for a minute. Now, the stacking is easy when you know the answers already. But the important thing I want you to notice, the biggest mistake I see people make is they'll get like 5 to work, and then they'll put a 2, they'll write this whole thing again, and they'll use all these same damn numbers. Why does that make no sense? If 5 works, here, can somebody start doing a prime factor tree for 48? How can you split 48 up?
24.
24 times 2. Would you then go, okay, let me start over at 48 and do 3 times 16. Does that make any sense if I'm trying to make a prime factor tree? If I'm trying to factor it completely? Or would you take 2 and 24 and start going with 24? Hell yeah. So the minute you get something to work, this shit don't exist anymore. This don't exist anymore. Any other number I'm going to try it on what I got, because that's like the 24. I'm not going to start at the beginning again. That's insane. I see people do that. I'm like, no. And the extra little thing I haven't even said yet. There's one more thing that will reduce your list. The minute you get something that works, do you see how the last number is now a -8, not a -40 anymore? I mean, a +40? Do you see how that would decrease the size of your list of things that to try? I don't know if you guys are with me or not. Why was our list so big? Because the last damn number was a 40, yes. The minute I get something that works, the last number is not 40 anymore. Where'd it go? Here. So that would cut my list down potentially by itself. Now, real quick. Does anyone think, can we factor that further?
No.
Why not? Yeah, you can't find factors of 1 that added before. If you can, well, actually, again, they do exist. They're just not whole numbers. So there are no factors, whole factors of 1 that added before. Okay. What if I want, what are all the zeros? Can somebody just tell me the zeros?
5.
You can read it off right here, right? That's a 0, that's a 0, that's a 0. That is not all the zeros. How do I know that's not all the zeros? What was the power, the highest power on the original problem? 5th power. What's the fundamental theorem of algebra say? It was in that video we watched, but I want to bring it back. The number of answers you have to a polynomial, the number of intercepts, is equal to the degree. It's a 5th degree. I have to have 5 answers. Did any of these have more than a multiplicity of 1? Did they show up more than once?
No.
No! So how many more answers do I still have?
2.
Why did I not get them? Because they're not rational. Where would I get the other 2 answers from? Yes. And how would I get the answers? How would I get the zeros? What do I have that exists? Quadratic formula. And they could come out complex, or they could come out just not rational. What does not rational mean?
Irrational.
No, just
Irrational.
true. What does that mean?
Fractions.
No, fractions are ratio null, right? Rational means fractions. So anything that you can't write like a fraction, like square root of 2, which is exactly the kind of output I expect from the quadratic, right? So can anyone find the last 2 zeros, please? In fact, let me see how I do this. Everybody find the last 2 zeros, please. There's 2 more zeros to find. We got 3, and I know there's 5.
I got it.
This will be 5, 2, -4, -2 plus or minus red 3. Is that what you got?
Yeah.
So -2 plus. So here's the 5 zeros. 5, 2, -4, -2 plus or minus red 3. So can anyone tell me? See if you guys are cool with this. Okay. Can anyone tell me how many negative rational roots we got? Negative rational roots. How many negative
1.
rational?
3.
Negative, right?
Oh, rational, my bad.
Yes, rational.
1.
We got 1 negative, and how many positive? 2. And what was the prediction we made? So I always got to be careful with real, should be rational. Did we say we'd have 2 at most? And we said we'd have 3 or 1. And why didn't we get 3? Because 2 of them were irrational. So they could either be irrational or complex.
And then negative, it would be negative rational roots, not negative.
Yeah. I always mix that
That's
up
why I
at the
was
beginning.
like, what?
Rational.
Real roots, or real numbers include both rational and irrational numbers.
Yes. So here,
Can you pull down a little?
yes. Let me give you this. Probably finish this up. I want to take a look at some of these. Okay, so we already got all that stuff. Okay, so if I look at this, could you guys try out these first three here? I think that's, yeah, we'll see. I'll try to catch up to you in a minute. Oops. Yeah. Let me see. It's concerning. Oh, I see. Okay, okay. Damn you, Jeff. I talked myself out of the right way to look at this. Okay, let me really make this clear. It's been a while since I've talked about Rene Descartes, or Renard. Real quick, just go with me for a second here. I started down at myself, but now I'm better. -2 minus rad 3. Do you guys agree that's definitely a negative number, yes?
Yeah.
Okay. What about -2 plus square root of 3?
It's negative.
Because square root of 3 is less than 2. You guys, let me make sure you guys are with me. Isn't square root of 3 less than 2? Because square root of 4 is 2. So -2 plus a number less than 2 is negative. So how many total negative real roots did we get?
3.
1, 2, 3. Yes. So it was real. I'm right. But I doubted myself for a minute. So it was 3 negative real roots we got. Right? 1, 2, 3. And it was 2 positive real roots we got.
Rational.
Real. I should have stuck with my guns. Real.
Oh.
Yeah. In my head, I looked at that and I thought one of them was positive, and I thought, okay, did I remember wrong? Was it supposed to be rational? But no, it's real, the real roots. All right, so how are we doing on this? These should be relatively quick. Yeah? Where'd it go? Where have I put you guys? There you go.
Oh, you're not trying to find the zeros. You're just trying
Nope,
to
I
find
just want
possible.
the list of all possible rational zeros. So this one's not too bad because the first number's a 1. So what'd you guys get?
1, 2, 3, 4, 6,
And that's the turnaround point because that's the square root of 36. So then
9.
9, 12, 18, 36. Okay.
And only negative.
Well, oh yeah, sure. But just for this, list all the possible zeros. If I then evaluate it with Descartes' rule of signs, it would just be the negative ones. I haven't said to evaluate it with Descartes' rule of signs, did I?
Okay.
So these are all the possible ones. If I then said, like I do down here, what does Descartes' rule of signs say for the following? Then you can say there's no positive roots yet. What about this one? This one's not too bad, even though there's a number, not 1 in front. What do the top come from? 1 and 2. And the bottom? Crazy. So if I'm going to have fractions, I want this. So I'll either be 1 over 1, 2 over 1, or 1 over 2, 2 over 2. And of course, 2 over 2, I've already got that listed. You don't have to repeat. So some of your fractions will actually reduce to things you've already written. Don't write them again. They'll make your list look bigger. And of course, this one is the one that's a little more evil. Where do the top 1, 3, 9? The top always comes from the last number. Yeah, I don't need it. Here's already. 1, 2, 3, 4, 6, 12. Okay, so what I'm gonna get? I'm gonna get 1 through 9. I always get those 3 because it's over 1. 1 half, 3 halves, 9 halves. 1/3, 3/3 is 1, 9/3 is 3. I've already got those. 1/4, 3/4, 9/4. 1/6, 3/6 is 1 half. 9/6 is 3 halves, which I have somewhere. Do I have 3 halves somewhere? That's what you're trying to be.
Okay.
Is everybody kind of with me? I'm just doing each one, and then 1/12. 3/12 is 1/4 I've already got. 9/12 is 3/4 I've already got. Oh my God. Not only is that a big ass list, but it's also got a ton of freaking fractions. Yeah. So obviously, if I had a problem like this, I would give you a lot of ways to chop down the size of it. This is bad enough, it's big, and then it's got fractions. Okay. We'll finish this up next week. You guys get out of here. Fortunately enough for today, so.
Did this get to 5.6 yet?
No.
Okay.
5, 6 is where we talk about asymptotes and stuff, so.